Praise be to my God and Savior Jesus. So guys, I'm going to walk you through some of the variables that I have used in this particular script. So the script that I have developed is called Elroy Parkour script, and these are the variables that I'm using. So I'm just going to walk you through all the variables that I'm using. Okay. So the first one is scan height and scan depth. So whenever I jump, the scan starts. So scan height says how far above the player the scan starts and how far below does it go. Okay, not exactly the player, because depending on what kind of scan I'm doing, so either the scans will be from the chest. So for example, when I'm jumping, it will be from the chest. When I'm moving from right or left on the ledge, it will be from the shoulder. So with respect to the chest, it starts at this height. And scan depth says how far down below it goes. Okay, so that is what scan height and scan depth means. And we have these four variables: forward scan, start distance, and end distance. Okay, so start distance is with respect, so in this case, when you jump, the scans are with respect to chest. So the forward scan says with respect to the chest, the ray cast will start at this distance. So in this case, ray cast will start at 0.2 unit and it will go up to 0.5 unit from the chest. So if this is my chest here, it starts at 0.2 and it goes at a step of 0.1 unit. So 0.2, 0.3, 0.4 and 0.5 unit. And precision step comes into picture when any of these scans actually return a hit. So for example, if you go here, okay, so in this case, the first scan did not return anything, the second, third did not return anything, and the fourth scan actually hit something. So what happens is, between the fourth scan and the third scan, the program again, the script again does these, does some, lot of other scans at this interval. So between just the third and fourth scan, it will do every 0.01 unit, it will do ray cast, and it will try to find a point as close to the edge as possible. So this is what determines how close the player is close to the ledge. Okay, you see, in my case, he is pretty close, he is right on the edge. So because it is 0.1 edge, so if you make it 0.05, then he will probably be up to 0.05 unit away from the ledge. The hand will be in that position. Okay, so we will eventually see how we determine that position also, how far from the ledge and everything. So this is for the forward scan, and forward scan happens when the player is jumping and trying to find the ledge. Okay, and then there is side scan. Side scan happens when the player is trying to move on the ledge. As you can see, forward scan is like one line, and so let's say 4 ray casts along a straight line from the chest. And side scan happens with respect to the right shoulder or left shoulder. Let me just show you. Sorry. Show you the ray cast. Okay, you see here. Just a little clear up. You see? Okay, so side scan happens like this when you're trying to move right or left on the same ledge. Remember, this is not jumping. That is a different logic. We'll go to it later. We'll go to it soon. Okay, so here the thing is, the side scan start distance and side scan end distance are not actually talking about the ray cast, but instead the shoulder position. Okay, the hand position. Let's say the simulated hand position. So this is supposed to simulate the hand wave. So you're moving your hand from it's like the character is moving his hand from right behind him to right to his front. Okay, and he is trying to see if there are any ledges where his hand is. Okay, so that is what he is trying to do. So side scan start distance and end distance talks about how far from your shoulder the scan starts and where it ends. So in this case, it will start from 0.75 unit, which is this point, and it will go to right about the shoulder, right on the same spot as the shoulder, right shoulder or left shoulder, depending on which direction you are trying to move. So for example, what will happen is, first a set of ray cast will be done at 0.75 unit from the shoulder and at this angle, and then again from this angle, so until it finds the ledge. So if no ledge is found until this position, it will just go back and it will start at 0.65 unit and it will do another set of scans like this. and it will keep decrementing slowly until you're about right at the shoulder. Okay, so that is what start distance and end distance is talking about, and the step in which the scan has to be decremented if the first set of scans fail. So again, these three are not talking about the raycast distance like we saw before. It is instead the hand position from which the scans will start. Okay, so previously the scans were starting from the chest, but in this case the scan, they're technically not starting from the shoulder either. From the shoulder we are displacing the hand, and from the hand we are doing the raycast. Okay, and sweep start angle and sweep end angle. So in this case the sweeps will start from 90 degree to minus 90 degree, so which is right behind the shoulder to right in front of the shoulder. So this settings work for me because of the levels I was testing. So depending on realism, depending on your level, you may want to tweak this. And side scan sweep step. So it is like this angle we'll do it at 10 degrees, so from 90 I'll go to 80, 70, 60, 50, 40, 30. So that is how I'm going to do. So this sweep step says how this angle is incremented or decremented, and the scan distance is the actual raycast scan distance. So from the hand the scan will happen between 0 unit and 0.2 unit at steps of 0.1 unit. So as you can see, from this is the hand position initially, and it has done two raycasts, 0.1 0 and 0. Sorry, just a minute. Yeah, 0, 0.1 and 0.2. Similarly 0, 0.1, 0.2. So likewise it has done the scan until it has found a ledge, and as soon as it found a hit, it has done a precision scan again. So there is the same, pretty much the same logic, just like we have done here, but the only difference is instead of doing it from the chest, it is doing it from the hand, and the hand is again displaced at a certain distance and a certain angle from the shoulder. Okay, so pretty much that is what's happening. So right or left scan, this is what happens, and then we go on to leap scan. Okay, so we'll come back to threshold angle, but before we start this, so leap scan is pretty much the same as the side scan, but only difference is, as you can see, side scan happens horizontally. Leap scan is when I want to, for example, when I want to move from this ledge to this ledge. Okay, so I cannot move just by using WASD key. So I have to jump from this ledge to this ledge, and it has to be at a certain angle. So what I'm doing is I'm considering the mouse position with respect to the center of the player. So that's what I'm going to show you now. Okay, so the player is up. Okay, so if I want to jump to this ledge, you can see, so you see the scans are happening at a certain angle. So for example, I'm going to press A now, scan is horizontal, D now, scan is horizontal, and now I'm going to do a leap scan. See, you see, so that is the angle in which I am doing a leap scan. So it is exactly the same as side scan, but instead of being exactly horizontal, it is at a certain angle depending on your mouse direction. Okay, so that is what this does. And one thing to note here is this threshold angle and threshold breach start distance. Let me demonstrate this to you. So for example, in this case, okay, so in this case, the angle between this position and this position is over 25 degrees. Okay, so what will happen is the scan can happen between 0.5 unit and 1.2 unit. I will demonstrate this to you. Sure. Sorry, I pressed D. Sorry. Okay, so you can see here. So look at the distance of this scan. Just remember this. So it ends about right here, a little bit beyond the border. So let me just change the angle now. Okay, so let me just move this ledge a bit down. So it is less than 25 degrees. So now I'm also spacing this a bit away. You can see the scans are a bit longer here in this case. So in the other case, the scan stopped right about here. And in this case, the scan has gone up to this spot. Okay, so the scans are longer. So what I was trying to achieve here is, I want, the more horizontal the jumps or leaps are supposed to be, the farther the character can go. So that is what I wanted. So that is why I have implemented this. So if the angle for leap is over 25 degree on either side, so it is going to be, the jump is going to be up to maximum 1.2 units. So if it is more horizontal, less than 25 degree, so then he can jump up to 2 units to the right or left. Okay. Yeah, spaceman. And one more concept here is, remember there are differences between, I am differentiating all ledges as plateau and ledge. Okay, this is a plateau because the player can obviously climb over it. And this again is a plateau. I'm just trying to show you guys a ledge. I think this will be a ledge. Okay, he will have no trouble climbing here because there is nothing above the player that is blocking. So I'm not checking if anything is blocking when the player is moving. So that is some check that we may have to implement. So for example, okay, this again will be a plateau. This again will be a plateau. The player can still climb above it. So what I'm going to do is, I'm going to move this a bit below. As you can see, the player cannot climb here. So I'm pressing W button here. The player cannot just climb over it because obviously it doesn't feel, fit the criteria for being a plateau. Okay, so we'll go, as we go further, we'll see how we are enforcing these kind of checks. Okay, and these are movement settings. This is mainly what I'm using for my third person character controller. But in the end, this is a very, very basic. Only reason this controller exists is because I wanted to demonstrate this particular, this scene. So it is not full-fledged. It is very bad. So do not use it in your game. And I'm not going to walk you through this. Okay, so just don't worry about it. Okay, and then the animator reference, I made it because I'm using IK to position the hand, mainly to position the hand. Okay, and player character renderer, I need to, for some bounding box related calculation. Input translator is something I'm locally using just to get the inputs and translate it so that I can use it inside this script. And ledge layer, so the layer where we will do raycast and detect the ledges. Okay, so let me just show you. So ledge layer, you can see, so anything that is tagged as claimable, these are the only things that will be detected as ledger. So you can see these things are all tagged as claimable, everything here. Okay, and then let's scan start percentage. Okay, this is another key here. So it is actually not relevant when we are doing a sideway movement or a leap scan, but it is important when I am doing a jump. Okay, so once the character has reached about this percentage of jump, that is when the scan will start. So it doesn't start right away. So if it starts right away, as soon as you start jumping, it will just grab onto a ledge and stop moving to the ledge. So I want the ledge scan to start once the player has, lost around 95% of their velocity, of their initial jump velocity. Okay, and movement blocker layers. So this is another thing I'm using to detect, to prevent the player from going into the walls and everything. You see? Okay. So Okay, and pivot reference object. So this is something we will use eventually. Let me just pivot reference. Okay, so as and when we go further, I will just explain this to you. And the minimum ledge height, these are all used internally inside the calculation. Um, and then the hand fit size. So this is used to determine whether my hand will fit inside the ledge. So for example, if the ledges are like this, say something like this, even my hand will not fit in here. So I will not allow the player to climb here. So let me see if it works right away. You see, it is not even working. Just move it a bit further. You see? So at least our hand should fit there. So for it to be a ledge, our hand should fit. For it to be a plateau, our body should fit in the space. Yeah, and side leap angle check. So when I angle it too much from the player, so for example, here is the camera which is facing the same direction as the player. So which means the angle between the camera and player is 0 degree. When I'm doing this, there is no point in doing a side scan. Sorry, side leap scan. Sorry, there is no point in doing a leap scan. So which has to actually do a backwards jump and backwards scan. But that is something I haven't implemented. But using the same logic, using the components given here, you can also implement a backward jump. So, but this 80 degree is the limit. So, for example, if the camera is at this angle, I can do a jump. If the camera is at this angle, I can do a jump. But if a camera is at this angle, there is no point in jumping. So it needs to be a backward jump, which is not implemented. So maybe you can implement some kind of condition check. If it is over this angle or under this angle, initiate a backward jump instead of the regular sideward jump. Okay, and then the reference for hand. So these are things that I'll be using internally inside the program. So for example, instead of using transform, instead of manually having to calculate how big your hand is, what is the rotation and position of your hand in a given ledge, I'm using dummy empty objects. I'm rotating them, and then I'm getting their rotation back so that I can use in my calculation. So that is what these are for. So you see, I can show you. I have actually created them. This is hand position, player position. So player position will be right here, and the expected hand position will be here. So whenever we are hanging on a ledge, so my hand is supposed to be here, and the player is supposed to be here. So this is something we'll be using eventually for calculating the rotation and the position of the player, where they should be hanging given a ledge or a hip. And the climbing speed, how fast they climb from one ledge to another, from one position to another, and chest, the shoulder, right shoulder, left shoulder, and then the player state is used to identify what state the player is currently in. So you can see he is currently in ledge hanging. Okay, so I'll show you the difference here. So currently he is in a ledge, and if I move him sideways, still on ledge, still on ledge. Now he is on a plateau. He is hanging from a plateau. That is what it means. And as you can see, when he is moving, we are changing into ledge climbing. Ledge climbing. Similarly, plateau climbing and normal. So these are the states that the player has, and these are gizmos that I'm using for showing where the player is. So when I say gizmo, I'm not literally using gizmo. I'm using these objects. You see, this is my body gizmo, and there is a hand gizmo. I think I made it immutable. You see the position. Yeah, this is right where my hand should be. Okay. And these are things mainly I mainly use for debugging purposes. But maybe during the course of the tutorial, it will help you to understand how each of these components work. And body fit size and body fit reference. I don't think I'm using them, but let me body fit size. Yeah, I'm not using them right away because what will happen is the size of the body will depend on the player's bounding box. So it will be, I think it will be updated in the runtime in the program. So ledge detail, previous ledge detail, these are used to hold the details of the ledger, which I have been and which I'm going to be on. The direction of leap scan, which I need to do the scan. Leap scan override start distance. So these are local variables that will be used. For example, as you can see here, so this 1.2 and 2 will be put in this variable, and it will be used to call the logic, call the function or method which does the scanning and which does the reading. Okay. So these are all booleans that I'm using for my third person controller and for IK, and I'm drawing two capsules just to that is again for troubleshooting. I'll just show you. So it's these two capsules. So I initially had problems with incorrect collisions and everything. So these are the ones I used to troubleshoot. I have left it here because I think eventually I can use it to explain certain things to you. So these are the variables that are used in the program. In the next video, we'll start going into the script one after another.